Hello and welcome everyone. My name is Aron. I'm CTO and founding partner at Outlier Ventures, the organizers of Diffusion Digital. And we're here for the panel on No More Silos, building for interoperability in Web3. With me are Mark Miller, Chief Scientist of Agoric, Chris Goes, IBC Lead at Interchain GmbH, and Theo Turner, Lead Developer on Zip, project we incubate at Outlier Ventures. So we'll talk about interoperability between all of these systems. We've heard in the earlier panels about investing in technologies, building with these different technologies, and over the past years, there's quite a few of really flourishing ecosystems emerging around blockchains, around Ethereum, EOS, Bitcoin, Tezos, Cosmos, and many others. And those are all open systems, and that's great. But if we have many open systems and they're all a bit closed with each of them on their own, then aren't we building new silos? So that's what we'll go into now to see how can we bridge all these things and make sure that they really become one new Web3 rather than many new silos. So just to get start off, Chris, you're IBC lead at Interchain. So could you just very shortly describe your background and then tell us about what is IBC, what does it mean for firstly the Cosmos ecosystem, and then broader for other blockchain-based or decentralized ledger-based ecosystems?
Absolutely. I'm Chris. I lead IBC specification development at Interchain GmbH, which is the lead development arm of IBC and Tendermint in the Cosmos ecosystem. I think of interoperability as a design philosophy, not a single piece of software or a single protocol. And IBC only solves part of the interoperability problem. It's a fractal problem. We need to continue building interoperability. And as we layer on more protocols onto the protocol stack, there will be more interface boundaries, which need to be well specified to allow for interoperation. IBC solves a very specific layer of that problem, which is the base blockchain machine or consensus layer. So if you think of many heterogeneous blockchains, Bitcoin, Ethereum, the Cosmos Hub, perhaps some future Agoric chain or many Agoric chains, all of those chains have individual state machines which come to consensus separately. And IBC provides a protocol by which they can agree on a mechanism for validating restricted subsets of each other's state transitions so that they can send arbitrary packets to and from other chains. So from the developer's perspective, this looks a lot like asynchronous communication. Just like you might send a message, then later get another message back asynchronously, you can use that in like channels and Go. You will be exposed to that sort of primitive when you interact with modules on other chains or contracts on other chains over IBC.
Great. Yeah, so IBC is really quite a low-level protocol, right, for everybody's understanding.
That's right. Now, it's a low-level protocol that is built to be composed with and upon, just like the internet protocol. So we, colloquially say that we're using the internet, but when we're using the internet, we're actually using all of these different protocols at once. And IBC occupies, I guess it's higher level than the internet in some sense, because IBC needs the internet also as a protocol at an even lower level of the stack to be operational or useful at all. But IBC is lower than application level protocols, which you might use to send tokens or to engage in some sort of auction system using a smart contract, this sort of thing.
Great, thanks. Yeah. So Mark, similarly for you, could you very briefly tell the audience about your background, where you're coming from? And then at Agoric, you've recently released a first version or early version of Zoe. Do you like to know how that enables higher order contracting and what interoperability between chains means for Zoe?
Okay, so I've been working on smart contracting in one way or another since the late 1980s. Developed a vision of language-based, programming language-based smart contracting that enables programmers to much more intuitively and much more reliably write smart contracts with better confidence that the contracts mean what they think they mean, and with better partitioning of risk. We brought all of this together into the Agoric platform. The Agoric platform is a distributed object capability language embedded in JavaScript. I've been on the JavaScript committee since 2007, getting the enablers into JavaScript. And the object capability security paradigm enables us to build composable abstractions that partition risk. So Zoe, which you just mentioned, is our key framework for building composable smart contracts. And it brings two things to the table. One is what we call offer safety, which is that each participant in a smart contract on entering says what assets they're proposing to give, which get placed into escrow, and what assets they demand in return. And even if the contract itself is buggy, the Zoe framework guarantees that the participants have offer safety, which means that either they get back what they had given, they get refunded all of the assets that they had offered, or they get what they want in exchange. The contract, the worst that it can do is eventually just refund what was placed in and not make forward progress. So that's a tremendous bounding of risk. And then you have all the remaining issues of contract correctness are now an issue that's with regard to the remaining risk after offer safety is taken care of. The higher order contracting is that we have a framework called ERTP. That's the level of abstraction right underneath Zoe. ERTP is Electronic Rights Transfer Protocol. You can think of this as the analog of our tokenization system. It's a set of object interfaces that enables one to write contracts that work with fungible and non-fungible and a whole variety of different asset types. We're creating contracts and contract components that deal generically with a variety of asset types. And then when you create a contract, the invitation to participate in the contract is itself one of these kinds of rights. So this is the higher order composition, is that contracts manipulate rights, but any contract that unfolds over time, the right to participate in that contract is itself a right. So contracts create derivative rights, and then generic contracts and contract components can deal as well with base rights as they can with derivative rights. And this enables the kind of deep composability we're used to with higher order programming in functional programming and in object-oriented programming. So the reason that both of those paradigms are so rich, we're bringing the same kind of richness to market abstractions.
Right. So before we dive a bit further into the interoperability part there, for that I'll also ask a Theo question, but just as clarification, an example of such contracting rights, like if I were to purchase a concert ticket and I would want to resell that, or I would want some insurance on that. I've seen some good examples from your website, like how that would fit in that paradigm. Just give the audience a quick example of how that would fit in that contract paradigm for their understanding.
Yeah. So so first of all, when you buy the concert ticket, it's easy to resell it because anything that's within the system, e-rights are sellable through any of these generic trading abstractions. So you can sell it through an escrow exchange, you can sell it through an auction, etc. I'm sorry, what was the next part of the question?
Yeah, well, more like how that concretely would work for the example of purchasing a ticket and reselling it. So that would fit in the offer would be, okay, here's a ticket for sale.
Yes. Here's the ticket for sale. Here's what I'm proposing to give, and here's what I want in exchange, which is, let's say, a certain amount of a certain currency. For example, if you're wanting to sell that in an auction, I think this is the auction is a very good example where it shows you what risk is taken care of by the offer safety and what the remaining risk is on the correctness of the auction. So if you're auctioning off the concert ticket, then the thing that you would demand in exchange in making the offer would be taken by the auctioneer as your reserve price. And the concert ticket would be placed into escrow. You're hoping for more than the reserve price, of course. You're hoping for the amount that it goes for an auction. Each of the bidders would say, here's the amount that I'm bidding, and what I want in exchange is the contract, is the concert ticket. So as a seller through the auction, I'm guaranteed to at least get my reserve price or get my concert ticket back. Each bidder is guaranteed to either get the concert ticket or get their bid back. But the auctioneer could, if there's a bug in the auction, it can still misbehave in giving me only my reserve price, giving the ticket to somebody other than the highest bidder, etc. So taking care of the offer safety of the contracts leaves this residual risk. And then this is also an example of the general philosophy we have towards building these composable abstractions, is to partition risk. So different portions of your risk are dependent on the correctness of different pieces of code. One of the things we want to avoid is building a system that can only succeed if everything is perfect. That's the thing that we're most critical of in what we see elsewhere in the blockchain space. Is we want to have bounded risk from bounded bugs.
Great, thanks for that. All right, then first briefly for you, Theo, what is your background? And then on Zip. Zip is something that offers economic interoperability, as you call it. What is that, and how does Zip solve for it?
Thanks, Aron. My background is I've been at Outlier Ventures for coming up on 2 years now. I've been working as a technology analyst, chiefly within software development. The projects I've worked on are largely blockchain-based, machine learning-based, particularly looking at interoperability, developing integrations between various blockchains. A recent venture of Outlier is Zip, which is what I'm developing at the moment. Zip is economic interoperability, as you said, Aron. And what we mean by that is we look around in the blockchain space and we understand that many different projects are now addressing interoperability, but they are addressing technical interoperability. And at a high level, this can be sending call data from one chain to another. The problem with this is that you still need to manage all of the tokens of the individual chains. If I wanted to use Cosmos and Ethereum, I would need both Ether and Atom, and I would need to have the wallets for those tokens, and I would need to understand how to get those tokens and when to spend each one. So what we mean by economic interoperability is abstracting away that complexity of managing multiple tokens and having a single blockchain cloud credit that can be spent across chains.
Mm-hmm. Great. And could you tell a bit more about how that's realized in Zip? What's the approach to achieving that cloud credit?
Sure. So the cloud credit itself is a token, and that token is backed by a collateral pool of various other tokens. When we want to create a collateral pool, if we're just working with Ethereum, we can work with Ether and some ERC20s. We can send them all to an address, and then we can create some abstracted function redeem, which will allow our meter token Zip to be exchanged for any of the underlying tokens that need to be spent at any one time. For example, if I want to use Zip on Chainlink, then the underlying token link can be used. It's pretty straightforward for just working with Ethereum tokens. When we want to go cross-chain, what we need to do is actually wrap the tokens. So the first example of a wrap token was probably wrap Bitcoin, WBTC. Most people should be pretty familiar with it by now. Effectively, what we do is we look at another chain. Let's take Cosmos again as an example. We lock atoms, the base token of that chain, at a specific address. And we then have an off-chain listener which submits a release transaction on Ethereum for a wrap version of that token. So we basically create an ERC20 representation of the atom with a listener that allows us to release a certain amount of that in accordance with how much we've locked up on the base chain. That wrap token can then be placed in our collateral pool, and when somebody spends on that specific chain, the wrap token is unwrapped, and on the native chain, the native token is released to the target address.
Thanks. Yeah, so that's good to hear. And Chris, then from you, from your side, from the IBC side, what is the current state of IBC? I know that Game of Zones has been launched as sort of the working incentivized testnet and experiment to see how it all works out in practice. If that all works out, what is next for it, and also towards chains beyond the Cosmos ecosystem? What can we expect there?
Well, most of the answer to that question is out of my control. We built the protocol. We tried to make it solve the problems that we expect higher level applications like Zip, for example, who need a primitive interoperability protocol at the technical level between chains. We built the protocol IBC in expectation of those higher level protocols needs. In terms of our work in Game of Zones, the Game of Zones is an incentivized testnet, which means it comes with little contests and rewards designed to stress test the protocol to people how to use the software, as IBC requires not only developers to understand how to send and receive packets, but also relay or operators to perform physical data relay between chains. Game of Zones is ongoing. It's been pretty successful so far, and will wrap up in the next few weeks. Subsequently, we anticipate making a governance proposal to the Cosmos Hub to integrate the 1.0 version of IBC, which will of course be up to the token holders of the hub to decide to pass or not, or to modify. But the protocol itself is already released as open source software, which you can already download, use with the Cosmos SDK, start playing with, and as a complete specification. Implementations are currently ongoing in Go, in Rust, in JavaScript, and possibly in other languages as well. Once, optimistically, later this year, there will be many functioning implementations of IBC. There will be blockchains using it, and integrating IBC into your blockchain will be as simple as, basically modulo the complexity of performing a state machine upgrade in the first place, as simple as importing a new library that contains the basically IBC state machine, which can run as a module on your blockchain, especially if you're using the Cosmos SDK or substrate. Then updating your blockchain with that new library, and you'll be able to talk to chains which speak IBC immediately and start talking particular protocols like token transfer, or maybe like something like Zip, which could be easily written to run on top of IBC.
Yeah, I should mention the Agoric. Agoric is, together with Cosmos, is a major participant in building IBC. IBC is primarily a collaboration between Cosmos and Agoric at this point. And on top of IBC, Agoric is running CapTP, the Capability Transfer Protocol. And we're running that because our platform is one of distributed objects that are running across chains. So we have, at the object level and at the smart contracting level and at the rights level, interoperability between chains and non-chains, between public and private chains and consortium chains. Our platform is independent of the underlying consensus mechanism, as long as it can run our computational platform and communicate over IBC. We can run on top of it, and then we can interoperate at the market level and at the rights level across all of these different chains and across all of these different governance regimes. Yeah,
that's a good good bridge to like what I further would like to know about the approach and the technology of Agoric there, because the auction mechanism that we spoke about, that is a generic mechanism, right, on electronic rights. And here's then where interoperability comes in, because the more technologies and specifications like IBC get implemented, the broader the reach of such electronic rights can be. Correct?
Right.
Because I can only represent a concert ticket as an electronic right if someone decides to respect that thing that I have there to ultimately get into the concert hall when not everything has been cancelled. Also another interesting case, by the way, when it's cancelled, but let's leave it for another discussion. First within crypto assets, the moment where you can say, okay, I have here 2 ETH, 5 Tezos, and half a Bitcoin, and I would like to maybe pay the rent for my house for the next 3 months. That can be done, provided that these things can be represented as e-rights.
That's right. That's exactly right. We're trying to make the e-rights abstraction one in which it's general enough that a tremendous number of existing assets, including existing crypto assets, can be represented as e-rights. You can put an e-rights face on them, so that these other market institutions that manipulate e-rights generically can manipulate them. So that the auction, for example, you could be auctioning Bitcoin or auctioning a concert ticket or auctioning the right to exercise a covered call option. And you can be bidding in any of these things as well. And it's not just that the rights can be any of a variety of kinds of rights. The rights can also be located in different places and be running on different kinds of chains, where the different chains have different consensus theories. And the other thing that Zoe brings to the table is doing an impedance, doing an adaptation from the general asynchrony of rights being in all sorts of places in the world and on all sorts of different chains with different consensus mechanisms, to the need for trade, for exchange of assets to be atomic. So we do this asynchronous gathering into escrow and through pegging relationships of the rights needed to make an atomic decision. And only once all of the rights are gathered do you then make an atomic decision at one place, and then you asynchronously release the consequences of having made whatever that atomic decision is. So that turns out to be not just important for asynchrony, but important for heterogeneity across different kinds of consensus mechanisms.
Nice. And what you said previously about the partitioning of risk and making it clear what risks a certain contract or electronic right is prone to. I guess the further away you get from wherever your mechanism lives, the more types of risk are stacked on top of that, right? To say what I mean, if I am able to, at some point there is a splendid IBC implementation that integrates the Ethereum mainnet with the Cosmos Hub and with the Agoric Zoe chain at that point, and I have an ERC20 token, and it's a zip token, right? So if I would want to put that zip token in an auction in that way, it would be prone to the Ethereum consensus mechanism, the IBC bridge between Ethereum and the Cosmos Hub, then the Cosmos Hub to the Agoric chain. And if you can make those things explicit, then at least as a user and as a business, you know, okay, these are the things that I'm exposed to. And I'm willing to take those risks because I've seen the Ethereum blockchain work for 5 years now. Pretty sure it's going to work tomorrow too. Or there's a smart contract in that I'm exposed to along the way. Maybe not so sure.
Yeah. So good. That's exactly right. So the example of the concert ticket that you raised, I think, is a excellent place to start from that, which is somebody selling concert tickets. So you buy a concert ticket. Well, is there actually a concert going on? And is it actually worth listening to? Is the music any good? I mean, there's all sorts of issues that cannot be resolved purely within the technology. It's a question of what is it that's giving meaning to the rights that you're allegedly buying. So if I don't trust the governance on the Bitcoin chain, if I don't trust Bitcoin to have integrity, then trading in Bitcoin has less meaning to me, but maybe just as much meaning to the people I'm trading with. So we have this concept in ERTP of what we call an issuer. And for any given asset, there's the issuer that represents the meaning of the asset. So choosing to use that issuer, the identity of the issuer, is the reification into the language of objects of what is it that is giving meaning to the integrity of that asset. And that kind of philosophy also applies to which instantiation of Zoe, on what chain am I trusting, what contract is it that I'm interacting with through Zoe. Zoe itself will make the code of the contract visible and make visible what role each party is playing in the contract. But verification of code, which is what everybody else in the blockchain space is putting so much trust in, that's one aspect of of trusting the code, but the adversarial code understanding problem, which is what we have with smart contracting, is really quite hard even with formal methods, which is each party to a contract has an interest, some degree of interest, in having the other parties misunderstand what the contract means. So finding ways to bound that counterparty risk beyond just code verification is really quite important.
Thanks. Yeah. So it's not an easy problem, that's for sure, and not a one-dimensional problem to build interoperability between all these systems. As we approach the end of the session, I want to close up with a final short question for Theo. With Zip, what is the state of Zip, and what's on the immediate roadmap? What's in store?
Sure. So Zip is currently we're testing. We're on testnet. The code is all open source. If you want to go run it, build it yourself. It's on the Outlier Ventures GitHub. We are looking to launch relatively soon in the coming months. What we're focusing on at the moment is collateralization, and that is building our collateral pool so the product can work as smoothly as possible for its actual users. In building that collateral pool, we're signing with a number of partners. We're actively looking for new partners. At the moment, we have accrued a substantial collateral pool, and what we'll be focusing on in the coming months is building technical integrations between a few chains that are interested in interoperability with ours. One of those is Oasis Labs. Another, there are a set of Cosmos chains we also intend to integrate with. So technical integrations will be on the immediate roadmap. It's on testnet, and if you want to play around with it, feel free to build the code yourself.
Great, thanks. Well, I hope that somebody will build some low-level interoperability infrastructure and would make it easier, right? Good thing that many people are working on that. Gentlemen, thanks very much. This was super interesting. I hope it was interesting for you guys too. Thanks for getting up early for some of us. And yeah, I'm looking forward to a future of at least more interoperable blockchains and decentralization. Thanks very much.
Thank you.